Let's try solve for this pair of simultaneous equation. We have the first equation that was given to us as z over w. This is equal to 2 plus 2i. And I'm going to make z the subject. So z will be equal to 2 plus 2i multiplied by w. This will form for me the first equation. As for the second equation, I'm going to leave it as it is. So I'm given this multiplied by z. This is equal to 39 minus 11i multiplied by w. This will be equation number 2. And I'm going to substitute equation number 1 into equation number 2. So replacing this z, I will have a 1 minus 2i, then multiply by a 2 plus 2i times w. This is equal to 39 minus 11i w. And this is going to be very easy to solve because the question didn't say that we cannot use the graphing calculator. So I'm going to just make w the subject, and for whatever calculations, I'm going to just make use of our graphing calculator. So I'm going to bring this w over to the left hand side, which will give us a 1 minus 2i, then 2 plus 2i, which means that I'll have a plus 11i. Factorizing it out w, I will have this. This is equal to 39, which means that w here is going to be equal to 39 over this. So it is going to be over 1 minus 2i, 2 plus 2i, then plus 11i. Pressing this entire term here into the calculator, we will get w to be 2 minus 3i. Then I'm going to substitute this w back into equation number 1, which will give us z. So z is equal to 2 plus 2i multiplied by 2 minus 3i. And I'm going to just press this into the calculator again, and that will give me z to be 10 minus 2i. In here, we are given 1 plus ic to the power of 3. We are told that this term here, it is a real number, which means that the imaginary part of this must be equal to 0. And we are told that c here is also a real number. So what I'm going to do in order for me to find c is to expand this and then rearrange into the real plus I imaginary. So let's expand this. It will be 1 plus 3 times of ic, binomial expansion, plus 3 times of ic square and ic to the power of 3. So we will have a 1 plus 3ic. Then this I square is minus 1. So it is not plus, it should be minus 3 of c square. And I to the power of 3 is minus I. So minus I, c to the power of 3 is c cubed. And rearranging this so that all the real part of the complex number is put together, we will have this and this to be real. So 1 minus 3c square, this is real. And for the imaginary part, those terms that has I, we will have a 3c minus c to the power of 3. And since the question says that this is a real number, which means that the imaginary portion must be equal to 0. So we will let the imaginary part of 1 plus ic to the power of 3 be equal to 0, which is this. So 3c minus c to the power of 3, this is equal to 0. Factorizing out c, we have a 3 minus c square. This is equal to 0. This helps us to work out one of the possible values for c, which is equal to 0. And the other possible values of c's will be derived from the fact that 3 minus c square should be equal to 0. So c square is going to be equal to 3. C is a real number, so this works. And c can be either plus or minus square root of 3.